Hello and welcome. Today I want to introduce Kinect Lab. Kinect Lab is a project we are currently working on in our virtual reality laboratory. So, what's Kinect Lab? Kinect Lab is a project where we want to recognize gestures with the Microsoft Kinect. We want to use machine learning techniques for this purpose, especially neural networks. So in our first step we use a simple feed-forward network with backpropagation learning to achieve this goal. So let's see a bit theory about it. First of all, what's a gesture? A gesture is a simple set of some points in 3D space. So what we want now? We want some input variables, some suitable input variables out of this list of values. So we use the distance between two neighborhood points and calculate it just by using the Euclidean distance of x, y, and z coordinates. And in a second step we add a minus if the second variable is smaller than the first one. This is just a case because we need to know in which direction the user moves his hand or other track points, and for this purpose we need a prefix, because we lose every other prefix with the calculation of the Euclidean distance. So in our next step we add this calculated values to our input vector for our neural network. Next we repeat the step for each other points. So we have our input vector for our neural network and want our neural network to calculate our output vector. Our output vector is just a list of values where each value stands for a gesture. So our ideal values would be 1 for the recognized gesture, and all the other gestures or values should be 0. So in our next step I want to show you our application. So here we are. This is our startup window. We have 3 buttons: experimentation, which has no content right now, neural networks where we can train and create our neural networks, and samples where we can record new gestures. So let's see how to record a new gesture. Okay, so first of all I have to choose a sample set. This can be any kind of CSV file in our case, but I let it as the default, and I have to add some gestures. So I'll add a O and maybe another one A. So next I have to choose the sample rate and the buffer size. The buffer size indicates to the size of the input vector of the neural network. We can choose which points of the body should be tracked. In our case it's just the right hand. So now we are ready to record a gesture. For this case I have my subject Malte. So now Malte will record the gesture O. Let's see. Okay, very good. Let's save this and continue with training our neural network in the next step. Okay, first of all, let's choose another sample set. I recorded a sample set before, which represents the alphabet. So I've recorded 260 gestures, which represents letters in the alphabet. So let me choose this one. Next, I am able to choose the training algorithm. Right now we've just implemented the backpropagation training algorithm, so I have to use this one. And we want the user to be able to choose the parameters of the neural network. This isn't implemented right now, so I leave it as it is and just click Train Network. And like you can see in the output window, the error decreases over time. And we let the training stop if the error rate is below 1%. So right now the training has finished, so we can test our network. For this purpose I've prepared a set of sample data. So here's our output of our network. A lot of values, and like you can see on the end of each line is the ideal value. which we want to have. Like here, the second one from behind should be at 1, and let's see what it is. It's 0.912 and so on, so that's pretty good. And the other values are very slow, very small, and go to 0. That's what we want. We analyzed this data, and I want to show you what our results are. So, we used a dataset of 260 recorded gestures, 10 per letter. We used 7 for training and 3 for testing. So, what are our results with this dataset? We get an overall recognition rate of 75%. And like you can see, we have some letters which have really good recognition rates and got recognized all the time. On the other hand, we have some letters like the D, which isn't very good in recognition. So we can see it on another graph better. Here we got a graph for the F. Like you can see, we got very good results for this letter, because it's very unique, and you don't draw another letter like you draw an F. But if you look at the D, we haven't so good results. That's because we have many similarities between D and P, for example. And the neural network isn't able to classify well between these two letters. So we have to use some more unique gestures if we use backpropagation learning algorithm and feed-forward network. That's our first result. So it's a lot of work to do, but I'm finished for now. If you have any questions, just email us, and yeah, goodbye.